Welcome back to IT Project Management. In this module, we're going to talk about project quality management in as far as the project process and the project output, that is the product, are concerned. Note that in this module, we're going to make the jump from the project planning into the project executing phase. Here's what you will learn in this module. You will learn to describe the Pmbok area called Project Quality Management and how it supports plan quality, perform quality assurance, and perform quality control to provide continuous improvement of the project supporting processes. You will also dive into some of the more common quality initiatives and management systems, for example, ISO certification, Six Sigma, and the capability maturity model for software engineering. And then you will learn how to apply the quality concepts, methods, and tools that we have learned to develop a project quality plan. Let's go. Before we step into the details of project quality management, it's important to understand the dependencies between quality management and the lifecycle model you follow for your project budget and schedule. Quality is obviously a huge factor in delivering a successful project and in generating measurable organizational value. So yes, we need to manage schedule and budget as is shown here in a waterfall context. But bringing a project in on time and on budget, but without, number one, checking with the project sponsor and your end users whether you've built the right thing, or number two, without checking that your deliverable actually works as intended, that is a major project risk. Because when it comes to quality in, say, the software that controls a ventilator in a hospital or that monitors temperature in a nuclear reactor, you may not have any second chances to get things right. Quality matters. Big time. So optimizing the measurable organizational value of your delivery, that is, finding the sweet spot between schedule, budget, and quality, becomes easier when you pick the most appropriate project lifecycle. We have seen that if you know what you're going to build or deliver and your engineers know how to do this, maybe have done this many times before, your risk of getting it wrong is low. You may even have already tested code modules or hardware assemblies available that can just be integrated in your delivery. In such a case, a predictive or waterfall project structure is appropriate. If you and your client, however, have a vague idea as to what your deliverable is supposed to look like, but you're fuzzy on the details or you expect that major aspects in the design will change, developing in small increments and testing frequently is your ticket to success. In that case, you will want to turn to an adaptive or agile management model. In the event that you're building something very complex and new, or that you have many subsystems whose delivery you need to manage, a hybrid model in which you pick the best aspects of each of the previous lifecycle models might be the most appropriate. Again, your goal in selecting the lifecycle model for a project should be to produce the best quality output you can get. To ensure that you build quality right into your project, ensuring that your user will accept what you build is crucial. That is why the best projects start not with a huge technical requirements catalog, but with what's called the voice of the customer. That's a term from a management field called Six Sigma. We have encountered this voice of the customer in user stories or use cases that we find in an agile product backlog or in a waterfall scope statement. Most importantly, just like many things in project management, user stories follow a certain structure. Based on this structure, developers will start building quality into the process by writing the test scenarios and test cases first. That way, they will really know how the user wants to use the product, and they will engineer the product in such a way that it will pass the test cases. This makes it more likely that they will have built the right thing from the beginning and can devote their time to making it work correctly every single time it is being used. Of course, processes require people to perform them. In fact, a quality process is only as good as the quality of its workers. That's why Scrum, although quality is built into the process through its iterative testing first approach, the short sprint time boxes, and the opportunity to use the sprint retrospective productively to improve the development process, can still fail if the engineers are not good at working in a team or are too stressed to produce quality code. While there are more opportunities to catch up if deliveries are being missed, that catching up can quickly occupy too much space in the sprint, so that agreed upon sprint backlog items may have to wait until later sprints, which can snowball into the entire delivery being late. That can produce a lot of stress for developers and engineers and can lead to a decline in work quality and early career burnout. This is where the more relaxed Kanban method might help. Instead of on time boxes and review rituals, Kanban concentrates on flow, measured flow really. On the Kanban board, you can track the status and the location of a work item in the production queue immediately. Since work in progress limits restrict the number of items in a queue in order to focus on producing deliverables rather than unfinished parts, developer work is essentially flexible and can take many forms. This variety can make the workplace more interesting and less stressful. Lastly, Kanban can be used with time boxes or without, but its lowered rigidity can lead to better outcomes and happier people all around. So now let's take a look at project quality planning. The project quality management knowledge area in the Pmbok looks rather thin, doesn't it? But looks can be deceiving. As we will see, a lot of standards, metrics, and math hide behind these three processes. And as we're talking about project quality management, remember that we're preparing to step into the next of our 5 phases, the executing phase. Quality management is all about metrics. The old saying, "You can't manage what you don't measure," is the theme song. Remember the in-scope, out-of-scope columns in the project charter? Quality management. Those key performance metrics from your project charter? Quality management. In fact, quality management is everywhere on a project because when you're the project sponsor and spending a lot of money, you want to get the best value for your investment, right? But how can you determine what best value is? How can you tell that you are really getting the best product possible? That is what the project manager will have to prove using, can you guess it? Metrics. So now that we know that projects just crawl with metrics, here is what metrics should be. They should be specific, so we know what exactly you are measuring. They should be measurable, meaning that the data you're collecting are clearly defined and consistent, so they can be gathered over a period of time. They should be attainable, meaning that there are no barriers to obtaining the measurement data. Realistic, meaning that they make sense in the larger context of product and project development, and they should be time-bound, meaning that you have a defined start and a defined end and defined intervals at which you're collecting the data. In a waterfall project, all of these metrics are checked constantly during the execution and monitoring and controlling phases. And you've already seen that they're being collected and graphed almost daily in an agile model. The goal of quality management is to make sure, and at the end to prove, that your project has built the product that the client wanted, meaning that you have paid close attention to the product specification in terms of requirements, use cases, or user stories. It is also to ensure that your product works and that it is as bug-free as possible. Of course, quality standards differ between organizations. How strict they are is often related to the risk of their products. A web page or a mobile app would have less risk to human life and property than, for example, the control software for a brake system in a car. Not surprisingly, the focus of quality management is customer satisfaction. You may have seen metrics for customer satisfaction as 5 out of 5 stars and product reviews on various shopping websites. That's what we're going for. Only that in quality management, this looks a bit different. A project manager's customer is the end user. That's where measurable organizational value shows its true face. If the user happily uses the product, you get 5 out of 5 stars as the project manager, sort of, but we'll discuss the quality of your job later. If your project comes in on time and on budget, but your product breaks all the time, or nobody wants to use it because it's confusing or ugly, then you have failed. This is why it's so important to build quality into the production process, so that you build the right thing the right way from the very start. This will prevent many bugs from showing up in the testing cycles, so that at the end of your production cycle, whether that's the testing phase in the Waterfall project or the multiple testing cycles in each sprint of an Agile project, you won't have very many bugs to take care of, and your fixes can be finished and deployed quickly. This is why you've seen the continuous improvement bullet points in earlier modules of this course. In order to build a better product, we have to constantly be on the lookout for ways to improve how we build it. And looking for these improvements in our build and management processes is everyone's responsibility in an organization. And how do we know how well we're doing? Well, metrics. There's another kicker when it comes to quality management: money. Putting good quality management in place requires money. This is called cost of quality. Cost of quality typically breaks down into two factors: cost of good quality and cost of poor quality. Let's talk about the good news first. If your organization decides to invest ahead of time into cost of good quality, you can avoid the much higher and later cost of poor quality. So what is cost of good quality? Cost of good quality is the investment it takes to prevent quality problems from showing up at the end of your production cycle. This can be the cost to spend extra time on testing and audits to make sure that you've followed best practices and all legal requirements. It can also be prevention costs to make sure that you've planned all your supplier audits, internal peer reviews, and any other checks and rechecks to ensure that you deliver bug-free code and error-proof systems to your customer. This is especially important in a waterfall cycle where you have longer development periods and testing comes at the end of development. This is where iterative models like Agile with their small development and testing cycles provide a natural insurance already. That insurance is typically against cost of poor quality. Cost of poor quality, honestly, happens when your organization doesn't believe in prevention. If you're lucky and you find your product problems before they reach the customer, you're looking at internal failure costs, such as rework, delays, downtime, or even scrap, meaning that what you just built is not usable and you need to start over. If you are not that lucky, you will be looking at external failure costs, which is when your product doesn't work for your customer or even becomes dangerous to their property or their life. Just imagine software for brake sensors in a car. If that isn't tested thoroughly, people can die. Same with control software for a nuclear power plant. So cost of poor quality usually covers lawsuits and legal fines against your organization for bad performance. Part of the cost of poor quality is, of course, also that your organization will end up in the news, and not in a good way. So now we have to ask ourselves, how much risk for cost of poor quality is acceptable so that we don't overspend on cost of good quality? This brings us to a cost calculation that every organization has to do at some point, and the math looks different based on the organization or the industry. In healthcare, the last consequence is always that someone's health or life is going to be at stake. So any quality improvement projects, often called Six Sigma or lean projects, are crucial to ensure the patient safety while looking for opportunities at cost reduction. In other industries, like commercial IT, for example, internet storefronts or product review sites, typically lives are not so much at stake. So any investments into Six Sigma or lean quality improvement projects will be smaller. The graph here shows that the sweet spot of just enough lies where the investment in quality protection measures, that is the cost of good quality, crosses the line of quality problem management, which is the cost of poor quality. This is also where the total cost of quality is the lowest. So when we plan our quality management, we have to plan for two things. To ensure that we build the right thing and do so the right way, following all the best practices and rules that we know, which is something everybody in our organization is responsible for, and that we ensure we have built a quality product and caught all the bugs and issues as early in the production cycle as possible. The first one I mentioned, where we ensure we have followed all the best practices and rules and have done our prevention activities, is quality assurance. In a waterfall setting, quality assurance is most visible during the execution or build phase, but stretches across the entire project lifecycle from initiation to closing. The second one I have mentioned, where we test our deliverable not just once or twice, but many more times, is called quality control. Now both of these are critical in a production and delivery cycle, no matter whether you're using waterfall or agile, because you certainly want to reduce the risk for any cost of poor quality. Now if we superimpose on this the famous 4 steps of Edward Deming's quality model, plan, do, check, act, then plan goes with planning quality, do goes with quality assurance, because you're monitoring how you execute your project. Check goes with quality control, because this is where you check your deliverable. And act goes with continuous improvement. In an iterative project format, continuous improvement is a natural part of the project lifecycle, because after each sprint review and demonstration, we hold a sprint retrospective to apply any lessons learned from the previous sprint right away to the next one. In a waterfall lifecycle, any quality improvement is less regulated and mostly occurs in the closing phase, in the lessons learned process after the product has long been delivered. Any lessons learned can only be applied to the next project, but they're too late for this very project, unless something goes very wrong in the middle and improvement becomes an emergency. No matter whether you're running a waterfall or an agile project, you will often need a separate project quality plan. This is because project quality may not be your thing to assess and audit. Often outside auditors from regulatory bodies such as the government may want to look at your project and product, especially if you work in a public industry such as utilities, or in a high-risk environment, such as the automotive industry or aerospace. Here is a breakdown of what a good quality plan should include at a minimum. Note that you will have to provide detailed information about your quality planning steps, about your quality assurance, and about your quality control. And remember that the quality plan always needs to be approved by the project sponsor and many more folks, most often all the way up to the COO, the Corporate Operations Officer. But how can you prove that you're doing these three? Quality planning, quality assurance, and quality control. Well, for quality planning, the output is your quality plan. And for quality assurance and quality control, if you guessed metrics, you would have guessed correct. Because you can't manage what you don't measure. At this point, we have seen that there are essentially two quality dimensions to every project: process quality and product quality. There are also a lot of frameworks that are used to enforce or audit these, from Six Sigma or the older but still famous Total Quality Management, both metrics-based process improvement and control frameworks that may be coming at you from your operations department, and then process audit frameworks such as the ISO 9000 family or Cmmi or many others. There are also process awards such as the Baldrige Award. We will take a quick look at the approach and tools of the most popular ones, including verification and validation, knowledge management, and lastly, configuration control. A framework that's popular across many industries is the Cmmi Framework. Cmmi stands for Capability Maturity Model Integration. It is a process and behavioral model that helps organizations streamline process improvement and encourage productive, efficient behaviors that decrease risks in software, product, and service development. Cmmi was developed by the Software Engineering Institute at Carnegie Mellon University in 1986 and is now administered by the Cmmi Institute, a subsidiary of ISACA, the Information Systems Audit and Control Association. It is required by many U.S. government contracts, especially in software development. Cmmi starts at level 1, where your organization is basically in chaos. Nobody knows how to do things because nothing is written down, or nobody follows any rules that may be written down. Everybody is always putting out fires. This means your output is unpredictable. Customers who need quality probably won't want to do business with you. Level 2 means you have basic policies, processes, and controls for managing a software project in place, and you and your colleagues know enough about your work that you can repeat previous project successes. But your output will still be low quality because you don't have any standards in place. This means they'll also be high risk for your customer. They still won't want to do much business with you. Things get better at level 3. At level 3, you start writing and implementing standard operating procedures so that every project manager in your organization follows the same rules for managing projects, and so that the most important activities and approvals are listed in a guiding document, often also called a methodology. Project managers will follow the methodology. Now, as we're going from level 3 to level 4, that is where the magic begins. And that magic starts with metrics. At this point, you're not just making a project schedule and some sort of budget because you have to. No, at this point, you are actually tracking your project's performance and risks and reporting your metrics into the organization. This means that quantitative metrics for measuring and assessing productivity and quality exist for both software products and services and processes, so that the quality of your project output becomes quantifiable and predictable. This is the level at which we can start talking about measurable organizational value, because here is where you can prove that that's what you're generating, and your finance department will have enough data to back you up on that claim. The level of quantitatively measured is a huge thing for organizations. This is when they can start applying to work on American government contracts because project output will be of high quality and low risk. Now, it can't get much better than this, right? Well, Actually, it can. That's where level 5 comes in. In level 5, your organization is not chaotic at all anymore. Instead, it is completely data-driven to the point where you can focus on making process improvements that will allow you to produce your project output faster and cheaper, but with the same or even an improved level of quality than before. Another really important area of quality management is validation and verification, or V&V. The activities around validation are focused on answering one major question: did we build the right product? As such, validation is the activity that puts quality assurance into action, meaning that we follow all the rules and know all the specifications of the product we are supposed to build. Verification puts quality control into action. Its activities, especially testing, are focused on the question: did we build the product the right way? As we have just learned, testing is the central activity in V&V. There's a great number of test activities. We are seeing the major 4 in this table. The first activity is called unit testing. Unit testing is done by the developer herself or by a colleague on her team. It is very similar to a peer review, only that a peer review looks at the code mostly. Unit testing instead actually exercises the functionality that the developer has built, either with knowing each line of the code, that is white box testing, or not knowing the code at all, that is black box testing, or knowing the structure but not each line of the code, that is gray box testing. Unit testing does require a test plan and ensures that all modules work as programmed and that they are well written and safe from a security standpoint. A level up from unit testing is integration testing, in which the new code, once it has passed the unit test, is connected to other code with which it interacts. This tests whether the new code clobbers other needed output files or libraries, and that data flows successfully in and out of the new module with the desired results and actions. Integration testing is also called regression testing and is done by the developer in collaboration with a separate independent testing team. At this point, the separate testing team will log bugs in the bug tracking system, and those bugs will need to be fixed and retested in order to advance the new module to the next step. This next step is system testing. Here, the entire system, that is, the entire application or database, which includes the new module, is being tested. At this level, which is entirely executed by the independent testing team, we often find performance tests, such as smoke tests, to ensure that the newly built module does not cause any processing lags or overflows anywhere in the system. System testing is also often called performance testing. The testing team will log bugs at this point too. All of the bugs will have to be fixed to progress to the final and biggest step in your product testing. That is user acceptance testing. Here, the end user, that is the customer, gets to work through all of the user stories or product requirements and to determine whether the product that your project built can be used or not. Naturally, you want the product you put in front of the user to be as bug-free as possible because, believe it or not, your end users will find crazy, new, and inventive ways to break your product and send you back to the lab to fix it. Bugs found during user acceptance testing are usually reported to the project sponsor and higher management, so it is in your and your team's best interest to prevent those by imagining during development all the ways in which users can possibly misuse interfaces and functions in order to error-proof your product from the very beginning. Remember cost of good quality, right? A major factor in delivering a quality product is that we know at each moment what the latest or the most correct version of the code is that we are hoping to deliver. Many developers have a really questionable way of naming their code files that won't let you see it immediately which version of the code they want to include in the final product. This is where configuration control and software change management comes in. You have probably heard of GitHub, which will track the version of the code files you have uploaded and even show the changes between two files that have the same name but different modification dates. There is a ton of these systems out there, based on how and where you like to store your code. The main point is they all provide answers to these 4 questions. What changes were made? Who made the changes? When were these changes made? Why were the changes made? Because tracking this information is super important when it comes to ensuring that you use the latest and greatest files from which to build your final product. Here is the official Pmbok definition of configuration management. Please pause this video and read it out loud to yourself. Then come back. Supporting activity for great quality management is ensuring that all the knowledge that we develop within a project is documented, backed up, and stored for future use. This includes especially any lessons that we have learned from our mistakes and the opportunities we have realized when things went really well on our project. It also includes any documentation, whether user manuals and training or technical specifications, designs, data flows, and help desk cheat sheets. Lastly, the minutes of the meetings in which major decisions were made or approvals promised, those are also incredibly important. All of these project assets and more can help future engineers, developers, and project managers improve the products they build and the methods and tools they use to build these products. This knowledge management is the first step towards continuous improvement. Of course, quality management would be useless without metrics. Pause this video and take out your project charter, then come back. Look at your business case field. The root and at the same time the goal of all project metrics is really the measurable organizational value. As we have seen previously in this course, the MOV translates into the key performance indicators in your project charter that measure how you are going to transform the project scope into the reality of the product. These key indicators, along with the organizational standards, form the project standards for your product, as shown in this box. Each of these standards belongs to either product, process, or project, and is measured, as you can see on the right side here, by metrics. The process metrics focus on the effectiveness of identifying and removing defects or bugs, and the product metrics focus on the quality of the deliverables and satisfaction of the customer, client, or sponsor with these deliverables. The project metrics are a whole other animal, as we will see in a separate video. Here are some of the most popular metrics that organizations use to track projects. Again, you see the split into process, product, and project. Please pause this video now to read through each of these categories. Note that the project quality measurements, that is the metrics by which the company decides, among others, whether you are a good project manager or not, and you should keep your job or not, are important enough to make it into another video. Now take another look at the process and product metrics we have just seen and ask yourself the following questions. Which of the metrics in this table do you consider useful? Which ones are hard to measure? Which ones are easy to measure? Which ones would you measure once during the project, and which ones would you measure weekly? Then make a list. Which ones will interest your project sponsor, or your development teams, or operations? Now that we're at the end of this module, let's review what you have learned. You have learned to describe the Pmbok knowledge area of project quality management, from project quality planning to the actual management of project quality. You have also learned what the difference is between quality assurance and quality control, and how validation and verification tie into this, with the 4 different levels of testing, from unit testing and integration testing to system testing and end-user acceptance testing. You have then learned about the more common quality initiatives, and we have looked at the 5 levels of CMMI in detail. Lastly, we have discussed what all goes into a quality plan, and you have seen the outline for one, complete with a discussion of all the metrics that should be tracked for process and product. The project metrics will be discussed, as said before, in a separate video. Here are the words that you have learned in this module. Please ensure that you can define and explain each one of them. Thank you for watching. I look forward to seeing you in a future video.